Hi, welcome to demonstration of the new EasyIO plant control kit. Currently supports staging up to 10 stages, or up to 10 stages have been tested at this stage, and sequencing of up to 10 pieces of equipment with fault rollover. We'll just do a quick demonstration of how to get started with the kit. There's two types of staging objects. There's one staging object that accepts one input. This can be a temperature, can be kilowatts, anything you like, and there's also another object which can handle two different variables with individual set point control for each input and timer control for each input. Today we're just going to focus on the return water staging. So the return water staging has an enable, by default is off. Normally this would be linked to a plant control object, say cooling call or a heating call. Have a hold current stage. If you enable this, then the staging object will not stage up nor down. Stage 1 always on. With this set to true, whenever there's a plant call, the staging object will automatically go to stage 1. Number of stages, we can define how many stages we would like this to stage up to. It has been tested up to 10 stages. Today we're just going to choose 3. Temperature in is a variable that we're going to be staging against. Stage up, stage down set points. Now these can be reversed, so if the stage up set point is lower than the stage down set point, it just changes the action around of the loop. So it can be used for heating or cooling of say boiler or chiller plants. Stage up delay, stage down delay, again these in minutes, and then our stage up time remaining, we have these are in minutes and these two are in seconds. And stages is the total number of stages requested currently. So quickly create a couple of objects here. We'll create one constant which we'll link into our enable, just as it could be our cooling call. We'll also create a writable float, and this we'll use as our temperature. So we'll set that at the moment to somewhere in between our set points of 13. Okay, so we've also got a plant sequence object here, which is designed to work with our staging objects. By default, it's enabled. Number of stages. How many stages are we going to have? So this count also includes a all-off stage. So stage 0 is included in the count. So if we've got 3 stages set here in our return water staging object, we want it to be the number of stages in there plus 1, because we count every piece of equipment off as a stage. So that gives us 4. Number of equipment, how many chillers, how many boilers, or how many pumps are we going to be controlling? That will be 3. Now these total stages, total equipment tells us how many stages and equipment exist within our plant sequence object. Currently there's nothing because we haven't created them yet. The stages requested. This is our input from our return water staging object, so we'll go ahead and link that now. And number of stages on, number of stages requested. So that's just feedback for how many stages are we requesting, how many are on. Same as the equipment, how many have we requested to be on, how many are actually on. Run calc period, 15 minutes. Currently this isn't used. And then we have these objects here. Let us invoke different things manually through our program, which at the moment shouldn't be used. They're to be used at a later date. So we've said that our number of stages should be 4. One of our actions is update app stages. If we invoke that, you'll see that our update stage config here turns to true, and shortly our total number of stages, there we go, changes to 4. Again, we've said how many pieces of equipment and define that, so we can update our equipment there as well. This will go through and create our equipment for us as well. And then we go total equipment 3, total number of stages 4. So if we come in and have a look into our plant sequence object, just arrange our objects horizontally, you can see that our equipment's been created for us and our stages have been created for us. Our equipment 1, 2, 3 by default, they're disabled. If they're disabled, they're just not used within the plant sequence control at all, including for fault rollover. So we want all of our equipment enabled to be set to true. Out of service, let's just take a piece of equipment out of service and will then be used with the fault rollover. You can see that our equipment number has been defined for us as well. Out is whether the equipment is on or off, and runtime and efficiency. So these can be linked to, say, totalizers. They can be linked to an SQL function block to query data within an SQL table to get efficiency or equipment value. For the purposes of today, I'm just going to put some values in. So equipment 1 for runtime, which is runtime's always an integer. Doesn't have to be runtime, just needs to be an integer value. Position of equipment 2, I'm going to say the runtime is 3, just to mix things up, and runtime of equipment 3 we'll set to 2. So we should have equipment 1, equipment 3, equipment 2. I'll also put some efficiency values in there. So efficiency of equipment 1 can be 10, 5, and we'll leave the last one at 0. Again, stage 1 doesn't need to be linked. Just spread these out a bit. Our staging objects. So looking at stage 1, stage number, total number of active equipment. Active equipment is equipment that is always supposed to be on within a stage. Flexible equipment is equipment that can exist in a stage, and the piece of equipment that's on is defined by the least runtime or the best efficiency. So if we define multiple flexible equipment, we have to define how many pieces of that equipment we want to be on, which is in the number of active flexible equipment. We also have rotate, runtime, and rotate. These are not used within the program. They're used. They're there for to update all the stages at once from the plant sequence object. These don't need to be linked. It's configured by this plant sequence object itself. A flexible type, runtime, can be runtime or efficiency. Runtime then rotates or positions the equipment according to the integer runtime value. Efficiency goes by the float efficiency slot value. Can also order ascending or descending. Pretty self-explanatory. And then we've just got some counts here, just more for monitoring purposes, and our out slot just tells us which stage is on. So for stage 1, we're going to say total number of active equipment. We just want one piece of equipment active. Standby equipment. This is equipment that can be used in a standby mode, just in case one piece of equipment fails. So we'll say we want 2 pieces there. Stage 2, going to say we want all flexible equipment, remembering that flexible equipment can be an active piece of equipment and can also be a standby piece of equipment, depending on the position. So for stage 2, we might want one piece of equipment, let's say 2 pieces of equipment which are active. So therefore, in stage 2, we've got 3 pieces of equipment available to us. 2 should always have an output on, and 1 is there in case one piece of equipment fails. Stage 3, total flexible equipment 3, and we want all of them to be on. So therefore, we select 3. Now, each stage can have its type of equipment, which equipment will run positioned differently. So stage 3 could be set to run efficiency. Stage 2 could be runtime. Stage 1 could be runtime and descending, or efficiency and descending. Again, you're not limited to just runtime values or just efficiency values. It's integer or float values. We can also link them all together so that we only have to change, if we decide we want to change the plant, we only change it in one spot and all of our stages change together. So now we've defined what type of equipment we want to run in each of the stage. We need to jump into our stages. So, okay, stage number 1, the active stage. Which equipment do we want to run? Okay, we might want this to be chiller 2 to run. Standby stage 1 could be chiller 1. Standby stage 2, chiller 3. So we've defined active stages and standby stages. Stage 2, we have flexible stages. So, flexible stage 1, equipment number 1, flexible stage 2, equipment number 2, flexible stage 2, equipment number 3. So we've defined the equipment here. Position isn't defined, runtime or efficiency at the moment isn't defined. This will be invoked once we update our plant sequence object, and we'll update all the stages at once. Stage 3, again, arrange objects horizontally, define our equipment, equipment number 1, equipment number 2, equipment number 3. Okay, we'll just put that back. Okay, 2 and 3. So we've got our equipment created, stages created. Go back here. Now, just for demonstration purposes, make it easier to see, we will create some objects here. So this will be out of service 1. Copy that. Let's just create a couple there. So we've got 3 out of service objects. And this could be our equipment enable 1. Copy, create them, and this will just let us see what's going on one screen. Make a link. So out of service objects, we want a link to our planned sequence equipment. So out of service 1, 2, out of service of equipment 1, out of service 2, to our out of service equipment 2, out of service 3, 2, out of service 3. We'll switch around now. So equipment 1 out. We want a link to equipment enable 1, 2, 3. Okay, just check our links. Out. Service. Okay. So we've got our logic created now with our sequence. We've got our staging. We've got our sequencing with 3 active stages, and we've got three chillers that are controlled. So we'll turn our plant enable on. So we're enabled. Our stage 1 always on. We always want, once we've got a plant call, we always want stage 1 to turn on. So we'll make that true. And you'll see stage 1 is turned on. Plant sequence object is turned on. You'll now see that we've requested So stages requested is 1, number of stages requested is 1, number of stages on is 1. Number of equipment requested is 1, number of equipment on is 1. And equipment 2 is on. So equipment 2 is our active stage. If we take that out of service, set true, you'll see equipment 2 turns off, equipment 1 has turned on. So now equipment number 1's failed, equipment 1 is turned off, equipment 3 has turned on. Should equipment 3 fail, then our equipment also goes out and will turn false. Actions, set false. So we'll put all of our equipment back into service. You'll see that equipment keeps running. Should this equipment now fail, you'll see that we roll back to our original active piece of equipment. And equipment number 2 turns on. So a stage up and stage down delay set 15 minutes. If our temperature rises above our stage up set point, you'll see that our stage up time is now timing out to stage up. Now we don't want to wait for the full 15 minutes, so we'll just override the up water delay. And you'll see that our stages now have gone to 2, which has then gone to our plant sequence object. We've now requested 2 stages. Number of stages on is 2, number of stages on 2. We didn't update our flex values to give us our positioning. And now we've got equipment 1 on and equipment 3 on. So if we have a look in stage 2, we've got flexible stage 1, which is position 1, with a runtime of 1, which is the least. Flexible stage 3, equipment number 3, position number 2 with a runtime of 2, and flexible stage 2, equipment 3, position 3. So the one important step that I've missed out there was once we've configured all of our equipment, we need to just update our flex values to get our initial positioning of our equipment. So we're now staging up. We can also take one of these pieces of equipment out of service, and we should roll over. There we go. Put back to service. And we're looking to stage up again, so we can override our up water delay. Now gone to stages of 3, and you can now see all of our equipment's on. Staging down similarly, once our variable gets outside, triggers our stage down limit. Our stage down timers will start. We can also override our stage down time. Stages have dropped down to 2. You can see that equipment enable 2 has dropped off, and we've still got equipment 1 and equipment 3 on. We can override our down water stage again, and again down to stage 1. You'll see equipment 3 drops off, equipment 1 drops off, and we go back to our stage 1 equipment, which is number 2. So that's a quick rundown of the operation of the staging and the sequencing object with variables that can be configured for runtime and efficiency. Again, these can be used with the SQL function blocks or programmatically calculated information through your programs. Hope it helps, and we'll be in touch with further updates. Thank you.